This tutorial is going to cover dynamic programming by taking a look at an example Leetcode question. This is Leetcode number 5, longest palindromic substring. And so why is this a dynamic programming question? How do we even identify dynamic programming questions? Well, a palindromic substring, well, where we first think, how can we break the problem down into smaller problems? If we want to find, let's say, sequences, the smallest palindromic substring, what's that? It would just be a sequence of 1. So right here, A is a palindromic substring, B is a palindromic substring, every single letter is a palindromic substring technically. Then we can move up. We can say, if we have sequences of 2 letters, how many palindromic substrings do we have? So the idea behind dynamic programming is to it's sort of like recursion, but put another way by storing the results of the recursion. So for this question, longest palindromic substring, what we want to figure out is we have these substrings and we want to know, are they palindromic or not? And we want to calculate all of the substrings and we want to know which one's the longest. So in this test string, we have, if we exclude 1-letter sequences, we have 3 palindromic substrings, which one is BB, which is a 2-letter palindromic substring. One is ABA, a 3-letter palindromic substring, and ABBA, a 4-letter palindromic substring. So how do we get started? Well, first we construct our DP table, which is it's going to be a multi-dimensional array of booleans. And to just create it, to initialize it, we're going to use the array class. And we'll initialize it like this. And so this will allow us to create a multi-dimensional array like this one. And we're going to fill that with false. So let's just output that and see what we've got. Right. As you can see, we've got a multi-dimensional array with the length of the input 5 by 5. Now that we've got that, our multi-dimensional array, if we access it like this, what does this mean? It means the substring from index I to index j is a palindrome. That's what we're saying, if that's true. So we've already decided that substrings of length 1 are palindromes. So what we can do is we can set this diagonal over here to true. Now that we've set all the diagonal, which is sequences of length 1, to true, what we now do is we start counting the sequences. So we're going to loop over all of the sequence lengths. So for let sequence length equals 2, we'll be starting at sequence length of 2. And while the sequence length is less than the length of the entire array, then we're going to increment the sequence length. And then for each sequence, we're going to check each position in the sequence. So for sequences of length 2, we're going to check this, we're going to check this, we're going to check this, we're going to check this. So for int I is equal to 0, I is smaller than or equal to s.length minus sequence length, because that's what we're going to check up to. So for example, for length of 2, we're going to check, you don't want to index to a range that we can't access. Okay, now for each of these, how do we know if this subsequence substring is a palindrome? Well, we can check the substring plus this new letter at the end. So that's our substring. And we already have this value because we've stored it over here in the diagonal, and we're going to keep building upon that. And so we can just check if the new letter and the first letter of the substring are the same. We're going to initialize this variable j, which represents the last character. I'm going to put this into VS Code to avoid j. So that means that the character at the start and the character at the end of the substring are the same. And what we want to check is if s of I plus 1, j minus 1, so the substring from I plus 1 to j minus 1 is a palindrome. So if we're checking sequences of length 3, what we're going to do is we're going to check is a at position 1, position 0, equal to a at position 2. We're going to say yes, it is. Then we're going to check is the index 1 to 1, the substring 1 to 1, a palindrome. Since it's a single letter, we already have that stored as yes, it is. Since it is, what we're going to do is we're going to say, then we know that from position I to position j is a palindrome. So at this point, this is the foundation. We're building a table. We're building a dynamic programming table which tracks the longest palindrome, which tracks every single palindrome for each substring length. How are we going to give the longest palindrome? We need to extend it with a record tracking mechanism. We need to track the record of the longest substring. So here, when we calculate, when we find that we have a valid palindrome, what we do is we say best start is equal to I. Sorry, if this length j minus I plus 1 is greater than our best length so far, current length plus 1. That's the current length of the substring. So if it was 2 and 0, it would be 2 minus 0 plus 1. That's a length of 3 for AB. If the current length is greater than the best length that we have so far, then we say that the best start is equal to I, the best length is equal to current length. Now this code has a slight issue for sequences of length 2. This is because A and B, that's position I is equal to 0, j is equal to 1. If we say I plus 1, j minus 1, I plus 1, j minus 1, then it swaps the positions. So we're comparing dp of 0, of 1, 0, which doesn't make sense. For our dynamic programming table, I will always be smaller than j. So we'll always have it be a triangular matrix with the top right triangle being filled and the bottom left triangle is never touched. So we have to just say that the conditions are the sequence length being 2 or the substring being a palindrome, and that's all. Then we have to just return the sliced string, which would be from best start to best length, because it's the number, not the it's the end and it's not included up to. So let's get this out on. Let's test it and see. Okay, here our mistake is that we need a this went one too far. I is less than s dot length. It only goes from 0 to 4. 5 is not valid. Here we need to check the DP table and not the string. And finally here we just need to do best start plus best length. Put that out on a tray. And there you go. Now you know how to solve any dynamic programming problem. 10 out of 10. Like and subscribe.